In this problem, we're going to be going over question 4 from the AP Calculus 2022 free response section. So we're given this table that gives us different rates at which an ice sculpture melts, but they tell us that it maintains its conical shape as it decreases in size. Now, for part A, it asks approximate R double prime of 8.5. Now, we're given values of R prime. So our double prime is the rate of change in these values, and 8.5 is right here, halfway between 7 and 10. So that means R double prime of 8.5 is approximately the rate of change from R prime of 10 to R prime of 7. So R prime of 10 is negative 3.5. Negative 3.8, excuse me. And R prime of 7 is negative 4.4. Now we got to remember we are subtracting always, but we are subtracting a negative. So that means it's 4.4 minus 3.8. So we get 0.6 over 3. So that means we have 0.2. But the thing is, remember, we have to indicate units of measurement. So R prime is centimeters per day. So this is our double prime. So this is centimeters per day per day. And oftentimes the way they'll have you write it is they'll have you write it as centimeters per day over day, like that. Or they'll write it as centimeters per day, like that. You can also write it in that form. Part B asks, is there a time on this interval from 0 to 3 where R prime of t equals 6? So these are the values of R prime. So the question is there somewhere in this interval where R prime is negative 6? Now at 0, it's at negative 6.1. At 3, it's at negative 5.0. Now, important thing to note is it's given by the fact that R is a twice differentiable function, which means that R prime is a differentiable function. Now, because it's differentiable, we also then know that R prime is continuous. Now, we need that in order to apply intermediate value theorem. Some people might think it's mean value theorem because it involves a derivative, but remember this function is already R prime. So we're looking at these values. So we consider R prime of 0 equals negative 6.1 and R prime of 3 equals negative 5.0. So that means by intermediate value theorem, so the y value that they give us is negative 6. So negative 6.1. So negative 6 is between them. So then so R prime of c will equal negative 6 for some value 0 less than c less than 3. Now, in some cases right here, you could put negative 6, or some people may say you should put in R prime of t. So we'll see when the AP comes out with their criteria to see if you have to put that. Letter C. Use a right Riemann sum with 4 subintervals to approximate the integral 0 to 12 R prime of t. So here we have a table, and what we want to do is we break this up into 4 intervals, and we want to use the right-hand side of each one. So the first interval is 3 units wide, and its height is going to use the left-hand side, negative 5. The second interval is 4 units wide. We're going to use the right. The third interval is 3 units wide. We're going to use the right, negative 3.8. And the last one is 2 units wide. So we're going to use negative 3.5. All right, so what do we have? So we've got negative 15. 4 times 4 is 16. And so 4 times 1.4 is 1.6. So this is negative 17.6. 3 times 3 is negative 9. 3 times 0.8 is negative 0.2. Negative 2.4, excuse me. So that's negative 11.4. And then over here, 2 times 3.5 is negative 7. All right. So I think what I'll do, just to make the computation a little easier, negative 15 and negative 7 is negative 22. Negative 17.6 and negative 11. These are nice because 0.6 and 0.4 adds up to negative 1. So then that makes that negative 12. With negative 17 makes it negative 29. So altogether, we have negative 51. All right. Now, it doesn't say to indicate units, but that means 57 centimeters. So this represents a change in 51 centimeters lost in the radius of this ice sculpture over those 12 days. Number 4. Here it says the height of the cone decreases at a rate of 2 centimeters per day. Now that is a constant rate of change, and that's important. It's not variable like the radius is. At time t equals 3, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time at 3 days. Now they give us the formula for the volume of a cone. Now both the radius and the height are variables. Now the problem is the height is changing at a certain given amount. Now the radius is changing on its own. Now a lot of common related rates problems will have you convert radius into height or height into radius, but I'm pretty sure you can't do that here because here the height of the cone is a constant negative 2. If that were true, then the height of the radius would be changing at also a constant. So I don't think we can do that. I think what we have to do is we have to take this formula 1/3 pi r squared h, and we have to take the derivative with respect to time. So dv dt equals 1/3 pi r squared, and so the derivative of h is dh dt. And then we have 1/3 pi times 2r dr dt times h. And so now we have to plug in all the values that they gave us. So if I jump back, now they said at time t equals 3. So at time t equals 3, we know the radius, the height of the cone changes at negative 2. That's a constant. At time t equals 3, the radius changes at negative 5. So let's put those in. So the height is changing, negative 2. The radius is changing at negative 5. Now we have to plug in our constants. So at that time, the radius is 100 and the height is 50. Now, one thing we can do to make the algebra a little simpler is factor out the 1/3 pi, because that's on both terms and we can just ignore that for the moment. All right, so we have 10,000 times negative 2 plus, so here we've got negative 5 times 2 is negative 10 times 100 is negative 1,000 times 50. So this is negative 20,000 minus 50,000. So that's negative 70,000. Let's not forget that. So negative 70,000 pi divided by 3. Now this represents the change in the volume. So we want to find the rate of the change with respect to time in cubic centimeters per day. So that is centimeters cubed per day. So that is our rate of change of the volume. Thanks for watching. If this video helped, please give it a like. And don't forget to check out all the other videos from the 2022 AP Calculus test.